Here is a very important video on applications of expanding and simplifying polynomial expressions. We'll take up a trinomial a plus b plus c whole square, and we'll see how this general formula can help us simplify many expressions which could be as complicated as shown here. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll derive a general formula for a plus b plus c whole square. Once we derive that, we'll take that learning and then apply it to expand and simplify the 5 expressions given here. It is important to apply and keep applying the learnings and connect with the given concept as we move along for a better performance. You may also like to pause the video and expand and simplify these polynomials and then look into my solution. Let's begin with the very first one, which is how do we expand and simplify a plus b plus c whole square, and then we'll apply that learning on finding the solution for x minus y plus 3 whole square. So let's begin with the expansion first. So I'm rewriting a plus b plus c whole square. So it really means that we'll multiply a plus b plus c by itself, right? Now that is simple. You could expand using distributive property. Now if you do that, multiplying with a, we get a square. And then with b, we get ab. And with c, we get ac. Now similar operation will be performed multiplying by b, all the 3 terms, right? So 3 more terms. So we again get ab plus b square plus bc. Now we'll repeat this with c. So we get ac plus bc plus c square. So in all, we get how many terms? We get 9 terms, right? So these 9 terms, you will also notice when I wrote them in alphabetical order, right? So, for example, when I multiplied by c, I did not write ca, but ac. Now, this is also a very important step. You simplify and you can see what are the like terms which can be combined. So, well, we have 3 square terms which are a square plus b square plus c square. And then let's look for like terms. AB, for example, we have another AB, right? Similarly, for AC, we have another AC, and we also have a term for BC. So they are repeated, right? So therefore, we can write this as plus 2 times AB plus BC plus AC. You get the idea. So we have 3 other terms which can be combined. And so we have now in all 6 terms as mentioned here. You get the idea. So this is easy to use and easy to remember formula. So a plus b plus c whole square is sum of the squares of a, b and c plus twice the product of their individual products, right? Sum of their individual products. You get the idea. So that is the formula. Now we are going to apply this formula to expand. So I've taken a very simple case, x minus y plus 3 whole square. And since we know that a plus b plus c whole square is basically equal to sum of the squares of a, b and c plus twice the product of these, right? So we could write product with a, both b and c, and then bc. You could write like this also. Anyway, these 3 terms will be multiplied with one another, and add it, then double them to get the result. Now in this case, we have the question which is x minus y plus 3 whole square, right? So now the value of a is x, b is minus y, right? And c is 3. So when you square, what do we get? Well, we get x square plus minus y square plus 3 square, correct? Plus 2 times. When you multiply the first two terms, we get minus xy, you see that? And then with 3, you get plus 3x. And multiplying y with 3, we get minus 3y. So that is how you could actually do it and simply take care of the signs. So minus becomes plus here and we get plus 9 plus 2 times. We can rewrite this as minus xy plus 3x minus 3y. Does it make sense to you? How simple it becomes, right? So we'll apply this couple of times so that you really understand how do we work with these types of questions. They are very common in any test, right? So now we have to expand 2a minus 3b plus 1 whole square. You can always pause the video, apply the formula. I hope you remember it. But I've also written it right there on the top, which you must have noticed by now. So we get now 2a whole square plus minus 3b whole square plus 1 square plus 2 times product of these. You can change the order if you want. But anyway, I prefer to multiply a with b first, which is 2 times 3 is 6 with a negative sign, ab, right? And then 2a with 1, so we get plus 2a. And then the other two numbers, which are minus 3b. You get the idea, right? So now you expand and clearly write down 4a square plus 9b square plus 1 plus 2 times minus 6ab plus 2a minus 3b. Makes sense, right? Simple as that, right? Let's do it a couple of times just to master this particular step. Now this is for you to practice. We have made a slight change here. See, we made x square inside this time, correct? Okay. It doesn't really make much difference because we're just looking this as a, right? So substitute x square there, square of that number. And I include the sign within the brackets. That makes things simple, right? Plus 2 times product of individuals. So when you multiply x squared with minus x, we get minus x cubed. And then we have plus x squared. And then you have minus x. You will also notice the method which I have used. All these polynomials are recorded in the right way. Highest degree first. You get the idea, right? Now we have here x to the power of 4 plus x squared plus 1 plus 2 times minus x cubed plus x squared minus x, correct? Well, in this particular case, you could factor out x also. So we'll rewrite this as x squared plus x to the power of 4. So what we did is we expand and then we are trying to simplify. You get the idea? So when you expand, you get 9 terms. And then when you simplify, you get a simpler version which is being shown here, right? So we could now factor this. If you want to factor, you could also factor minus 2, right? Sometimes in multiple choice questions, we could have this as your one of the choices, right? So 2x, do you see that? So I want to write this x outside, so I write minus 2x, and then it becomes x squared, and that becomes minus x, and that becomes plus 1. Makes sense? So you could also write the answer in this particular fashion. Perfect. Let's continue. And then now we have x squared minus 2x minus 3. So x squared minus 2x minus 3 whole square will be written as square of the terms, right? So important. Just take signs inside, negative signs, correct? And write positive outside. That makes more sense, correct? So 2 times product of this, so we get minus 2x cubed, and then minus 3x squared, and then plus 6x, right? So rewrite x to the power of 4 plus 4x squared plus 9 plus, so let me factor out x again. So we get minus 2x, right? So I'm factoring minus also. So it gives me x squared plus, this was 2x squared, right? So 2x squared plus 3x minus 6. You see that? So I changed the signs also since the outside term is negative. Now here is a test question for you. What we have done is we combined, we have made it more complicated, right? So if you look at this expression, which, let me rewrite this. We have x cubed minus x squared plus x minus 1 times x cubed plus x squared minus x plus 1, correct? Now there are 4 terms which are being multiplied. How am I going to do that? That's very interesting. If you notice that if I factor out negative, then these 3 terms have some similarity. So let me show you that first. So we have here, let me use square brackets. And in that, we have x cubed. And if I take minus outside here, then what do we get? We get x squared minus x plus 1, correct? That is my first term. And the second one, x cubed plus. And we have x squared minus x plus 1. Do you notice that? So it is kind of a cubed minus b, right? A cubed minus b type of a thing, right? So how do we expand this? So this is what now you have to look into, correct? So it is good practice to expand these terms. You see this is the same term as the other one, so it becomes a perfect square. Makes sense, correct? So when you expand, you get x cubed times the first term, right? And which is basically x to the power of 6, and then x cubed times the second term, which is plus x cubed times x squared minus x plus 1. And here we have to multiply with these, right? So x cubed I'm writing first times x squared minus x plus 1. You see that these 2 terms will cancel. That was the whole idea. And when you multiply this with the other term, we get minus x squared minus x plus 1 whole square. Makes sense? So now you see these 2 terms are same, they get cancelled. And what do you have? You have x to the power of 6 times minus the second term square. Perfect. So let's go to the next page, apply the formula which you just learned and do it. So we get, in this particular case, we are just continuing. So we get what? We get x to the power of 6 minus the square of the other term, which is x squared minus x plus 1 whole square. You see that? So that is what we get, right? So I'm just writing that simplified form, capital S, is equal to this, right? Now you know how to apply this formula, which we had been working with, and expand this one, right? So we get x to the power of 6 minus, let me write within the brackets, the square of these, right? So we get what? X squared plus minus x whole square plus 1 square, right? Plus twice the product of each combination. So first is minus x cubed, and then with plus x squared, and then the other 2 minus x. Do you see how easy it became? So that is how we are going to learn these strategies. You can now open this bracket and write these terms individually. So So we have, sorry, this was also square, right? X square whole square. So we have x to the power of 4 minus x square minus 1. Signs are changing because of the negative outside. So don't ignore that, right? That is very important. And here I'm going to take minus inside. So I'm writing plus 2 here, factoring out x, correct? Slightly complicated. And with this minus, I'm going to multiply individually. So I get x square. I have factored out x already. And we have plus x and we have minus 1. Make sense? So no, we have to change the signs because I'm multiplying with this negative, all the terms inside, not outside. You get the idea? So it becomes minus here and plus here. Perfect. So that is what we do. And I've also factored out one of these x's from here. So that is how we get our solution. Is this absolutely clear to you? Perfect. So you see how we began with perfect square of a plus b plus c, applied it to different situations, right? Let's get back to this. So we found that this perfect square was basically equal to the sum of squares plus twice product of individuals, right? So AB plus BC plus C. Correct? Easy to remember. And this formula can be applied in so many different ways, making this topic very interesting and useful. So one of the bonus question actually is based on this concept. So if you have understood, you are therefore very good result. I hope you understand and appreciate what we have done. Feel free to write your comments, share your views. In case you like and subscribe my videos, that'd be great. And if you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.